we'll just go over that quickly again. Okay, so if you remember a sine wave, 90 was at 1 on the y-axis when we were at 90 degrees along the x-axis, and 180 we were back at 0. Just because 180 degrees, we'd be flat again on the 0. We're on the exact same plane. Does this make sense? We would start here, and we eventually rotate back around to 0. Okay. The next time we are 1 away would actually be at -1, if you remember from the sine wave, which is down here, which is at 270. Well, that's not what I want to do. So at 270, so 180, 10, 40, 270. 270 is when we're at our next distance down, and finally, though this one doesn't make it, 330, we'll call that 360 over here.
And then it goes back to 0.
Exactly. This is imitating a full rotation of a circle. If you look, it's hard to see, this is going around, and if I were to flip this to the left, I would come back around. So essentially, this is our circle. If I were to flip, whoops, if I was to flip this part right here, back over here, it's supposed to complete a circle. Though I didn't draw it as the perfect circle, that's the idea. It's supposed to draw an entire circle there. So when we go over to take a look at this, that's what they're referring to, all of these measurements here. So we have our full rotation of a circle all the way around, we know is 360 degrees, right? So we have a 360 degrees, but that is also equal to the circumference of our circle. Since our circle's radius is 1, you can also represent it as 2 pi. The circumference of this circle is also known as 2 pi. Now what they've done from there is they've just broken this into fractions of a circle. Okay? So instead of going the entire all the way around the circle to 2 pi, let's say we only went halfway around. Well, halfway around 2 pi would be just 2 pi divided by 2, correct? That would be cutting it in half. In other words, that would be pi. We'd only have to rotate 1 full pi radian here. So they split it in half. So a full rotation is 2 pi. Half a rotation, or 180 degrees, is also equal to just pi. Say we're to only go 90 degrees. Do you know what that's going to end up equaling? We're cutting this pi again in half. So if I were to cut pi in half, how would I write that as a fraction? I'd have pi. Yeah, that's it. Half pi. Or, you can draw a little 1 here, but that's really irrelevant because 1 times pi is still pi. Right? So we cut that in half. How about halfway between 1 and 2? 1.5, right? So 1.5, but the way they represent it is a fraction. They call it 3 pi over 2. 3 over 2 is still the exact same as 1.5, or 1.5, right? So this is, if we make that a mixed fraction, remember 3 over 2 is really the same as 1.5. But we just always have to keep that pi. That's what's the important part here. We have that pi because we're dealing with the circumference of a circle. And then what you can do is you can split things in half from there. So what would, from 0, remember 0 and 360 are at the exact same point, right? So these are our radians. This is our 270. What would halfway between 0 and 90 be? Say we're just doing degrees, just in degrees. Between 0 and 90, what would halfway between that be? 45, yeah. So we have a 45 degree. So now what you can do, think of it as this number, our 1.5 pi. Once again, we're cutting that number in half. I'm referring to this number here. Okay, referring to that. If I were to cut it in half, how would I cut it in half? Do you know? So we go half of half.
Half of half.
Half of half. What would that be as a fraction? How do you represent that as a fraction? Half of half.
Wasn't sure.
Wasn't sure? Okay. What we can do is I'll show you. We can do our division. Let's jump over to the next page. Think of it like this. Half of half. So I have a half and I need to divide it by 2. Do you know the rules for dividing fractions at all?
Yeah.
Do you remember them? Okay. So to divide this, I'm going to have to make this 2 a fraction. 2 as a fraction is 2 over 1. And when dividing fractions, I can just make it a multiplication question if I flip this, make the reciprocal. Yeah, exactly. So you get a half, 1/4. So when we go back to our other page, 45 degrees is 1/4 pi. Okay? So we have 1/4 pi. Let's do another degree here. Okay? Do you know what this degree would be between 90 and 180?
I'm not too sure.
Not too sure. All you have to do is add 45 to 90. So you're going to end up at 135. Now it's the same idea here. We have to get halfway between half pi and pi. Okay? So we have to get it halfway. So in this instance, we're adding a quarter to a half. Okay? So I've rotated, think of this as I've rotated a quarter. Okay? So that's our 45. Now to go from 90 to here, I again added 45 degrees. Or it could be known as I added a quarter of pi. So I would add a quarter pi to my half pi. So let's go and calculate that on the next page. If I have 1/4 pi, we don't need to keep the pi. We're just going to figure out the fractions. Plus 1/2 of pi. Well, I got to make the denominators the same. So it becomes 2 over 4. 3/4 pi. So we'll go back over. This 135 can be represented as 3/4 pi. They usually write it 3 pi over 4. Yeah, they'll write it like that. But that's exactly what they're referring to. They're just cutting up circumference of a circle many, many times over. So what you'll have here is you have 30 and 60, right? So what you have to try to think of it as is, let's try to cut, well, you know what, I'll move over to another page because this one's getting a little messy. Let's go over here. We have our circle again. Okay. Let's think of it. Cut the circle in half. Half again. So we'll break it into quarters. See what time it is. I have to make sure we stop before 15 minutes because my thing can only record that long. Okay. So we go from here. We know that a full rotation, we have our 0 degrees or our 360, and a full rotation is 2 pi. 360, right? So that means half of that circle is just going to be 1 pi, and halfway between there is going to be 1/2 pi. Okay, that's also known as 90 degrees. This one is 180. Now, on your piece of paper here, if you notice, they've talked about 30 degrees and 60 degrees. Okay, so what they've done is they've kind of broken this piece of a pie. Think of it like a piece of a pie into thirds. Okay, so I went from 0 to 30 degrees, 60 degrees, okay, 90, we're going to do another 30 from there, which is 120 degrees, and they also have 150 degrees. So does this make sense to you here? This is, I've moved 30 degrees from 0, or I've moved 120 degrees from 0. These are all different options we have. This one's 150. We're going to try to rewrite these in radians. Okay, so we have to cut these kind of like into fractions. If you notice, I have 1, 2, 3, 4, 5, 6. I have 6 pieces. Okay, so right now I have 6 pieces. I'm going to need to rewrite these fractions. Okay, so I'm going to write them into sixths. So our denominator is going to be a sixth. because I have 6 pieces of a pie here. I know that this is 1 whole pie. We know that that's 1 pie, right?
Yeah.
If I were to write that as a fraction with the denominator 6, well, essentially what I'm doing is I'm writing 6 over 6 pi. It's still the exact same as 1 pi, because 6 divided by 6 is just 1. So because I've broken this into 6s, that's just so I can organize the rest of these. So if I were to go a step backwards from 6 over 6, 150, do you know what that would be as a fraction? If I were to step back 1 fraction of this pie. Exactly, yeah. So 150 is represented by 5 over 6 pi. Now let's take a look on your sheet. Do they have it? 150, 5, 6 pi. Does that make sense?
Yeah.
So then we step back again. We have
4, 6 pi.
4, 6 pi. What would this one be?
That would be 3.
3, 6 pi. But you notice they just reduced that fraction, right? That's why they write it as a half. They're always reducing it to the lowest form of the fraction. But it really is still the exact same as 3, 6 pi. What would this one be here?
2, 6 pi.
2, 6 pi. How else do they represent that? How can I reduce that fraction?
1/3.
Yes. So you'll notice in the book that I'm going to write that as 1/3, which brings us to this. 4, 6 pi can also be written as what? 2/3 pi. So all they've done is they've reduced all these fractions. But really they've cut it into sixths. Okay? Yeah, so that's all they're doing there. And this one here is going to be still 1/6 pi. 1/6 pi is the most reduced we can make that fraction. So essentially, technically 0 is 0.6, but we don't write anything. So that's how they represent these in radians. They've constantly cut these pieces of the circle into like a piece of a pie. That's exactly their idea behind it. Does that make sense?
Yeah, that makes sense.
Okay, let's try to cover some of your homework with this idea, okay? Okay, so question 2H on your homework. Okay, what page is this? 442, right? They're talking about a half rotation, or sorry, a quarter rotation. So a half would be all the way down. We have our y and our x. A quarter is just this far backwards. So they're just talking about going that way. So this would be a quarter rotation, negative quarter. So that's a negative 1/4 pi.
Oh, okay.
Yeah, and that's it.
Okay.
Have they put anything special on your circles at all? No, not really. No, there's nothing special about it. So that would just be a negative quarter rotation backwards. You're just moving around the circle by fractions of that circle.
What does like number 4 mean? Sketch the approximate location of the radian